Welcome to the first tutorial of Materials Informatics. So I'm Sogat Purohit, a PhD student of Professor Sai Gautam Gopalakrishnan, and I'll be with you for the first few tutorials of this course. So let's get started. So in the first tutorial, we'll go through the installations of Anaconda, that's a Python manager, and then we'll install the Python environment that's required for this course, and I'll also show you how to open and run Jupyter notebooks. And then we'll also look at the basics of Python. So Python is very vast, so we'll do as much as is required for this course, and we'll go through what variables are, how to write loops, functions, and finally classes. And we'll end with discussing a few modules that will be necessary in the course. These are NumPy and Pandas, and we'll also use other modules that we'll discuss on the flow when we discuss the codes. So to start with, let's look at how to install Anaconda. So we need to go to this website www.anaconda.com/docs/getting-started/miniconda/install. So Miniconda is a lighter version of Anaconda which we can install quickly. So we'll go ahead with Miniconda installation, and if you scroll all the way down in this website, you'll get quick start install instructions. And in this, you'll see various tabs here. So if you are a Windows user, you should select Windows PowerShell. If you are a Mac user or a Linux user, you can select the relevant commands here. We'll discuss instructions of installation in all these three machines. So let's start with installation on Windows. So select Windows PowerShell, and below you'll notice 3 lines of code. So what we have to do is go to our Windows machine, then search for PowerShell and open this Windows PowerShell app. So that looks something like this. Now, as soon as you see this command prompt, this is where you can type these commands that you see on the website. So let's copy paste all the commands one by one. So this is the first command. So as soon as we execute it, it might take a while, maybe 5 to 6 minutes. And once it's executed, you'll see the command prompt pop up again. So now again, just copy paste the second code, and once that is done, just copy paste the last code, and our Miniconda installation is done. Now to check if your installation is correct, if you search Anaconda PowerShell prompt, you should see something in the search tab like this. So if you can see this, your installation is fine. Now next we want to go inside this Anaconda PowerShell prompt. So this is our Anaconda PowerShell prompt open, and now we want to navigate to the directory where we have the environment file. So if you are unsure how to navigate using PowerShell, what you can do is create a new directory, say dedicated for the course, and then you can download this .yml file provided in the course material and put it in the same directory, your working directory. And then you can right click here and click on properties in this directory. And here you will find the exact location of the directory. For example, here it is C users Indira OneDrive desktop. So this is the parent directory of this directory, and the name of the directory is Materials Informatics. So let's copy this and paste the entire directory name, entire parent directory path followed by the directory name, and this should be after the command cd space. So type cd space and put the full path of the parent directory and the name of the directory and press enter. Once you do that, so your Anaconda PowerShell prompt should be in your working directory. Now just type ls and enter to see if you have the .yml file present in that directory. So if you do not see this YML file, you can download it from the course material and put it in the corresponding directory. And your YML file could be slightly different. So there will be different YML files for Windows, Linux, and Mac OS. So your YML file could read mi_windows.yml, for example. And once you have this, you just type the command conda space env space create, then -f, that stands for file, and space the name of the YML file. So this should be the correct name of the YML file present in your directory. And once you execute this, it will take a while and your environment should be set up. So you should see commands like this, and you might as well be asked to accept some terms and conditions. You can just enter A for all the accept commands that it asks for. And once that is done, your installation of the environment on your Windows is ready. Now you can type conda env list and press enter. You should see the name MI appear in your list of environments. So this star mark denotes which environment you are currently in, and this shows that MI environment is also there. So to activate this environment, you can type conda activate MI and then press enter. What you should notice is to the left of your command prompt, the base, the letters base should change to MI. That indicates you are in the materials informatics environment now. And finally, you want to open a Jupyter notebook from within this environment. So just type all small Jupyter minus notebook and press enter. So as soon as you enter this, you should see commands like this, and your Jupyter notebook should directly open on your web browser like this. But in case it does not open, you can see here that there is a http:// link. Copy this entire link and paste it on any web browser, and your Jupyter notebook should be open. So that is the installation with Windows. Now let's briefly look at how to do the same on a Linux or a Mac system. So again, let's go to the website, this website mentioned previously, then scroll all the way down and select the Mac OS or the Linux tab. Now within Linux also there are three sub tabs: 64-bit, AWS, IBM Z. So most likely you will have a 64-bit build, but if you have any other builds, like select the relevant tab, and then similar to Windows, we just have to execute these commands one by one. And similarly for Mac OS, so there will be two tabs, one is for Apple Silicon and one is for Intel. If you have a newer Mac, you select Apple Silicon. If you have older Mac before 2020, you can select Intel, and then follow these commands. So we'll briefly look at these. Now you have to run these commands in your terminal app. So terminal app is available both on Linux and Mac OS. So the right side one is the Mac OS, left side one is Linux. Now enter the terminal app and enter all the commands present in the website one by one. So this image shows all the commands run one after the other. And after this is done, after you have run all the commands, you need to close the terminal and reopen it. So once you have done that, once you have reopened the terminal, you have to type source ~miniconda3/bin/activate. Now note that tilde is the sign that is just below your escape key on your keyboard. Now once you type this, you should see base appear to the left of your command prompt. That means your Miniconda installation is fine. Now we need to navigate to the working directory. So if you, so before that, before navigating to the working directory, you can type conda init --all and execute this. So you will see some changes like this, and after you execute this, again just close the terminal and reopen. So as soon as you reopen your terminal now, you should see the base, the letters base to the left of your command prompt like this. And then finally move to your working directory. So if you know where your working directory is, just move there directly. Otherwise there are other ways. For example, you can use your GUI to create a directory and then right click on that directory and press new terminal at folder. So that can be done either on Linux or a Mac OS. So that opens a new terminal window in your working directory. So once that is done, type ls and see if your mi.yml environment file is present or not. So you can download this file from the course material, and this file can be named slightly differently. For example, mi_Mac OS or mi_Linux. Now once you have access to this mi.yml file in your current directory, run this command. So conda env create -f mi.yml. So this mi.yml name should correspond to the name that you have in your directory, to the name of the YML file. And this will take a while to run, and after this has finished executing, you can check by typing conda env list, and this should show you two environments. One is the base and the other one is MI, that stands for materials informatics. Now finally you can activate your MI environment, and after you type conda activate MI, you should see MI appear to the left of your command prompt. Now after this is done, you can just type Jupyter dash notebook on your terminal, and again your Jupyter notebook should automatically open on your web browser. If it doesn't, you can copy this link http://localhost etc. and paste it on your browser to open a Jupyter notebook. So this is how your Jupyter notebook looks like, and that's all with the installation. Some final takeaway points are: every time you open a Jupyter notebook, make sure that you activate the right environment, that is conda activate MI, and you always navigate to the right directory after activating, or you can navigate to the working directory first, then activate your environment, and then open Jupyter notebook from within that environment. And for opening it, you can always use Anaconda PowerShell on Windows and the terminal app on Linux or Mac OS. And to shut down your Jupyter notebook, you can go back to these terminal windows or PowerShell windows and press Ctrl C and ensure that you have saved all the changes before you terminate a Jupyter notebook. So that's all with the installations. Now let's go to a real Jupyter notebook and look at some Python basics. So I'll do that on the laptop. So here is my terminal, and you can see base here. So I'll activate the relevant environment. So for me the environment reads MT303. So I'll just type conda activate MT303. But for you have to activate your environment that you have installed, for example MI. Now once I've done that, I'll navigate to my relevant directory where I have my Jupyter notebooks. So for me that is ~desktop/materials informatics. So I'll navigate here and I'll type Jupyter notebook and I'll press enter. And the Jupyter notebook automatically opens on my web browser. So let's now go to 00A Python basics. So this notebook will again be shared with you in the course material. So let's open this. Now we'll go through the absolute basics of Python in brief, and these will be helpful for you during the course, and there can be new things that you come across, and we'll discuss that on the fly. We'll discuss that on the way if anything new comes up. So let's start with data types. So whenever you want to store anything in your code, you can store it like this. So you name a variable, say A, equal to, and then type whatever data you want to store. So for example, in this cell, we write A equal to 3. That means we are storing the integer 3 in variable A, and then we are printing A and printing the type of A. So to run this cell, I'll put my cursor here and press Shift plus enter. So this runs the cell and goes to the next cell. So this code runs line by line. So the first line is executed, A equal to 3. Then print A is executed. So it prints 3, and then it prints the type of A. So the type of A reads class int. So we'll look at what classes are later. But what this says is A is a integer data type, because we have stored 3 here. Now we can do the same by storing 3.0, and let's see what is the difference. So we have stored 3.0 in B, we print B and we print the type of B. Now we execute this, Shift plus enter, and we see B prints 3.0 and the name of the data type is float here. So if you have decimal points in your number, you see floats here. Next we'll look at another data type that is called list. So list is a sequence of characters or numbers or any other data type that are enclosed within square brackets and separated by commas. So for example, C equal to inside square bracket 1, 2, 3, 4, 5. So this is a list, and we again print list, print C and the type of C, and we see that this list prints out, and the type of this variable is list. Now one important thing is list, since list contain multiple data points, so how do you access any one of them? So you can access any one by mentioning the index of that list. So every list index starts with 0, that means 1 here has an index of 0, 2 has an index of 1, 3 has an index of 2, and so on. So when you want to access a particular index, you type the name of the variable and write the index number within square bracket. So for example, if we run this C within index 4, the fourth index will be printed out. So the fourth index is 5. So another example, maybe let's look at another example. So let's say C equal to 12, 24, 36, 0. So I need to separate my data points by commas in a list, and then let's print C. So we have gotten 12, 24, 36 and 0, and say now we want to access 36. So that appears in the 0, 1, 2, the second index of C. So if we just print C within square brackets 2, we'll get 36. So that's how the indexing works in lists. Now let's look at another similar data type called tuples. It's very similar to list with some differences, but the first obvious difference that you can notice is tuple is enclosed within round brackets instead of square brackets. And if you repeat the same, so D is equal to within round brackets 1, 2, 3, 4, 5, then print D and print the type of D. We see type, so D gets printed within round brackets, and the type of D is called tuple. Now indexing in tuple is also same as indexing in lists, and there is one more thing that I would like to highlight, that say you have a very long list and you want to access the last element of that list or a tuple, you can always index it as -1. So the last element of a list and tuple can be indexed as -1. So now D is a tuple here, and say we want to access the last element of this tuple, that is 5, we can type D within square brackets -1. So that gives us 5, and this will work with lists as well. And note that lists are written within square brackets, tuples are written within round brackets, but whenever you want to access a specific element within the list or tuple, you always have to mention them in square brackets. Now let's look at another data type called string. So string basically stores any character within inverted commas. For example, we want to write a few characters, say ML and AI for materials, and we write them within inverted commas. This can be single or double inverted commas. And we print E and print the type of E. So as we run this, we see these characters get printed, and the type of E is str, which stands for string. And indexing string is also similar to indexing lists or tuples, where every character in the string takes one index, and the indexing again starts from 0. So for example, if I want to index the first character of this string, that is E0, and if I run this code, I get M here. And remember, all blank spaces are also counted as characters. So for example, in the string E, it is written ML, then a blank, the space, and. So the space is actually the 0th, first and second index. So if I print the second index of E, I get a space here. And another thing to notice is, in your Jupyter notebook, you can always skip the last print statement. For example, E of 2, if I just run E of 2 in this cell, it prints E of 2. What I can as well do is type print E of 2, and that basically gives a blank here because 2 is a space. So if we try to print E of 1, it gives L because L is in the first index. Now if I want to print multiple of these, so say I want to print the first index, the 12th index and the last index. So and I run this. So all of these get executed one by one, but in case I remove the print statements here, only the last print statement will be executed. So the last one is S, materials, last character. And if I run only this, only S gets printed out. So if you are printing multiple things, it's always a good idea to enclose your print state. So enclose whatever you want to print within print statements. Now let's look at differences between lists and tuples. So the first difference is of course in their syntax. So lists are enclosed with square brackets, tuples are enclosed with round brackets. Now let's create two sample, let's create a sample list called C, which stores 1, 2, 3, 4 integers. And now let's replace the second index. So second index here is 3, so this is 0th index, first index, second index. Let's replace second index with a string ABC. So that is possible in lists. So you can store different data types in a single list. So for example, 1 and 2 are integers. Now I want to replace integer 3 with a string ABC, and let's see what happens. Let's print out C, and we see that the third or the second index has actually changed from 3 to ABC. And now there's again another method within list. So we'll discuss in detail what methods are. And one important method is the dot append. So our list now contains 1, 2, ABC and 4. Now let's say for some use case you want to append another data point to your list. So you can use c.append, and within brackets you can add whatever you want to add to the end of the list. So if I do c.append 6.3 and then print C again, I'll see the previous list is there 1, 2, ABC, 4, and 6.3 gets added at the end of the list. So the length of the list is increased and 6.3 gets added at the end. Now let's try to do the same with a tuple. So again, like list, a tuple can contain different data types in a single tuple. Now say this is the tuple. So the first data type or the 0th index is a float 1.0, first index is 2, an integer, second index is string ABC, and the third index is a list itself 1, 2. And before executing this, let's just see how this tuple looks like. So yeah, so it contains 4 data points, all of different data types. Now let's try to modify the second index to 4. Now the second index is ABC, so ABC is a string. We want to replace string ABC with string 4. Note that this is not an integer, this is a string because it is within inverted commas. Now if we try to do that, we get an error saying tuple object does not support item assignment. So this is the most important difference between tuples and lists, that once you create a tuple you cannot modify it. So it's a not modifiable data type. Now that's all for lists and tuples. Now let's go to dictionaries. So similar to lists and tuples, dictionaries are an iterable data type. That means it contains various data points, but the arrangement is slightly different. While in tuples and lists, your data type get automatically assigned an index value 0, 1, 2, etc. In dictionary, you have to provide a key value pair for all your data. So for example, let's look at a simple example here. So I want to create a dictionary C, and like tuples and lists are enclosed with different types of brackets, dictionary is usually enclosed by curly brackets. And say we want to store items similar to a list. Say we create a variable called C_list, and we store 1, 2, 3, 4 here, and I want to store the same data in a dictionary. So I have to do that by adding a key value pair for each entry. For example, if I want to store this, whenever I want to store 1, I have to assign a key to my data. So let's say that key is string 1, and I separate a key and value by a colon mark, and I separate different data points, different key value pairs by commas. So let's again store a key 2 and value 2 and a key 3, value 3, and let's print C. So this is how a dictionary looks like, enclosed within curly brackets, has a key and value pair, and each key value pair is separated by commas, and within a key value pair each key and value are separated by colon marks. Now this is an example dictionary. So F again contains multiple key value pairs. The first key is a conductor and the value is iron. The second key is prime number and the value is 3. Then the third key is a float 3.14 and a value is a string. And finally the fourth key is a tuple and the value is a list. And now if we print F and the type of F, we see this dictionary getting printed, the key value pairs that we entered, and the type of the data type is dictionary, DICT. Now as we could access various data points on a list or on a tuple, we can access the same from dictionaries as well. So for example, if you want to access the keys in a dictionary, you can type F, the name of the variable that stores the dictionary, dot keys, and then round brackets, and if we run this, we get the dictionary keys here. So our keys were conductor, prime number 3.14 and a tuple 1 to 5. So this is what we get. And now if we want to obtain the values of the dictionary, we can access them by typing F dot values and then these brackets. So we get the values. So the values were iron, 3, pi, string, and 1, 2, 3, 4, 5 list. So we recover these. And just as we indexed lists and tuples, we can index dictionaries, but we have to index them based on their keys. So let me print F here. So F has 4 keys, conductor, prime number 3.14 and 1, 2, 3, 4, 5. So if I want to access the value of the key prime number, I have to type F within square brackets. I have to mention the key in its proper format. So since prime number is a string, I have to provide the string prime number here, and if I run this, I'll get the value that is associated with the key. And again, like strings, we can modify the value of every key. For example, initially the prime number key was assigned value 3. Now I can modify it to 2. So I can mention F within inverted commas prime number and mention 2 here. And also we can add new keys to the dictionary. For example, my key did not exist in the dictionary. So I can add this string my key and assign a value to it, hello world. And if we print this, I see the prime number key has modified value of 2 and a new key appears, my key, that has a value of hello world. So dictionaries are mutable, so we can modify the value of an existing key or add new key value pairs. Now one important thing when we think about variables in Python, so if you are familiar with C or C++, you will find it a little strange, so it is important to mention. So let's look at what happens here. So let's look at these lines of code. So we assign this list to this variable. So variable A contains list 1, 2, 3, 4, and then we type B equal to A. So what this should ideally do is B should also contain the data that A contains. So now the variable B should also contain the list 1, 2, 3, 4. So instead of running the entire thing, let's just run these two lines, and let's print A and then print B. So both A and B contain lists 1, 2, 3, 4. Now let's modify the first element of B to ABC. So that is index 0. So you want to replace 1 with the string ABC, and now we print B. Let's run this. So we see B has the first element as ABC and the rest are unchanged because we modified B. Now what do you think A should contain? So many of you might think that A is not modified, but when we print A, we see A is also modified, although we did not modify it in the code. Why this happens is Python stores your data in specific part of your RAM and then assigns that data to a variable, and every equal to mark is actually the assignment of that data to that variable. For example, when you type A equal to 1, 2, 3, 4, basically this data is stored somewhere in the RAM, and A is assigned that the data that you have stored in the RAM. And when you type B equal to A, B is also assigned the same data. So now both A and B refer to the same data. Now, and when you change anything in B, actual data gets changed, and so both A and B refer to the changed data now. So this is one thing that you should be careful of, especially when you are solving tutorials or assignment questions. Now you can click here and read more details about this. Now the important part is, how do you create copies of your data if a variable only refers to a data point? So usually many data types have this method called dot copy, so that creates an actual copy of your data. But if it is not present in some data types, you can always type this. So for example, from copy import deep copy, and then create your data, and then pass your data from deep inside this deep copy function and assign it another variable, and this B will now refer to a separate data which is actually a copy of your actual data. So we'll look into the details of what these import statement means, what other different data types can exist. Now let's look at loops. So loops are used when you want to repeat a specific block of code multiple times. So there are majorly two types of loops in Python. So one is the for loop. So the syntax is like this: for I in iterable. So iterable is any data type that contains multiple data points, something like list, tuples or dictionaries. And there is another loop called while. So while takes in a condition. So we'll look at an example for both of these. So let's make a list, and this list contains 5 strings. So note that these are not floats or ints, these are strings because they are written within inverted commas. Now when we iterate through this, we write for I in A, and then we put a colon, and in the next line we indent our line of code, meaning that whatever is written in this indentation comes within the for loop. And when we execute this, we see that all of the elements in the list get printed one by one. So basically what happens is, I takes the values of the iterable one by one. So when you run this block of code, I takes the first value of the iterable 1 and then executes whatever is there within the indentation. So there is just one line of code that asks to print whatever value I takes. So I takes the value 1, so it prints out 1, and then it goes back and takes the second value of the iterable, so that is 2, and then it prints out 2, and it goes on and on till it reaches the end of the iterable, and after that it exits the loop. So to show that it exits the loop only after going till the end, so whatever I write here, so print hi, so this is within the loop. So every time your I enters takes a value of A, it will execute print I and print hi as well. And let me write another print statement outside the loop. So let me write print hello, and if I run this, hi will, since hi is this print hi line is inside the loop, it will be printed every time I takes a new value from the iterable, but hello will be printed only after the loop has terminated and the code has come to this line. So if I print this, So after 1 there is high, after 2 there is high, after 3 there is high. So high is printed every time the loop is run, and only after the loop ends hello is printed. Now let's look at while loop. So while loop basically takes in a condition. So condition always returns a true or false value. Now for example, a is equal to 1, and let me create a new block. So let me write a equal to 1 and write a condition here. For example, a greater than 2. So of course 1 is not greater than 2. So this should return a conditional, that is a true or false. So let me print this, and I see it prints false. Now if I make this less than, it prints true. So while always takes a conditional, and it keeps on going within the loop as long as the condition is true. For example, I have assigned a equal to 1, and I write while a is less than 6, print a, and then I increment the value of a by 1. So what this basically does is it prints the value of a as 1, and then it updates the value as 1 plus 1, that is 2, and then it goes back to the top and checks if 2 is less than 6, it is true, then it again gets in the loop, then prints 2, and again increments the value of a, and it goes on till this condition becomes false. So this becomes false when a is equal to 6. So it should basically print 1 to 5. So that's what happens, and you should be careful while using while loops, because if you mess up the condition or if you mess up the lines within the loop, this could run forever. For example, if I do not update a, so a always takes the value of 1, this will keep running forever and you'll have to terminate it by 4. So let's try what happens if I run this. So it keeps printing 1, and if you make such mistake, you can just press keep your cursor here and press this button, so which asks the code to stop. So it will force your code to stop here. So at times it might not work like it is happening here. So it will run till your code crashes basically, or all the space in your RAM is taken up. So let me just terminate this terminal and just open a new one to stop the code. So as you can see, this like infinite while loops can be pretty dangerous. Now the last thing that we do for this tutorial is let's finish the exercise that we started. So here's an exercise. So we have been given a list, and the exercise is to loop through the above list and find the sum of integers in the list. So I'll try to solve this. You can try to solve this along with me. So so let me make a variable named I. So and let me assign a value 0, and let's write a for loop where j iterates over a. So for j in a, I want to store I is equal to I plus j, and then finally print I. So this basically sums up all the integers here and within the loop. So j takes value 12, 21, 34, 14, 25, etc. And every time it takes a new value, it adds to the sum. So for better clarity, maybe I can replace I with the variable sum underscore. So it's important to note that there are some keywords that are reserved for variables. For example, sum here, it shows in green color. That means I cannot name a variable sum because it's a reserved keyword in Python. So I can always add an underscore here, and always take care that your variable names do not have spaces between them. For example, I cannot write a variable like this, sum space 1, but a variable name like sum underscore 1 is valid. So let's say sum underscore 1 and print sum underscore 1. So that's the end of the exercise. So for now, we'll stop here, and I'll meet you in the next tutorial. Thank you.